Hello, hello, there we go. Those of you at home, here's your warm-up, guys. Perform the following operations, writing your answer in scientific notation, and make sure that scientific notation is appropriate for each result. You're going to want to pause the video because we are ready to go. Here we go, everybody. Let's see here. Let's grab that. We're going to snip those out. Ooh, what's going to happen here? I've never seen that. Oh, wow, that was weird. I've never seen the snipping tool block itself before. Oh, it's because there's multiple instances? Hang on. Grr. Let's see here. So I need to close that one, and now I need to grab this one, and then I need to snip this guy. That's what happened there. Haha, okay. We're back in business, baby. All right, so this first one where I am, let's see here. Get there. More on that later, trust me. We are dividing these two Huh? I don't know what that was. We're dividing these two values, 7.5 times 10 to the 13th, by 3 times 10 to the 22nd. Let's see what we get and do. Sophie, welcome back. How was your trip? Yeah, what was your favorite part?
I don't know. There was just a bunch of expensive museums.
That's awesome. What was the most expensive? I would never pay $100. I could not do it. I could not do it. Even if someone had said, sir, you need to park here and it's $100 and I'll give you $1 million later. And I was like, never! But anyway, were you able to watch any of the videos while you were gone? That's okay. Do you think you know how to handle this, though? Let's try it. If it's not right, that's totally fine, Sophie. What do you think we're going to do with this? Oh, so you could expand it. Right. You could expand it and then divide it, but there's actually an easier way. So let's talk. It's okay, Sophie. It's okay, Sophie. We're going to come back to you. Look at this. I'm going to take your card, and then I'm going to shuffle it back down here. Totally fine. You're way good. Lamhe, what do you think we could try instead? Yeah, when we divide powers with the same base, we subtract their exponents. And 13 minus 22, I think, is negative 11. Is that correct? Is that negative 9? Whoops. So that'll be times 10 to the negative 9. But what times 10 to the negative 9? Alex, how can I find out what times 10 to the negative 9? That's exactly right. I can divide these regular numbers. It's just like power rules. Coefficients do whatever it says. Bases don't change. And then when we divide, we subtract the exponents. So 7.5 divided by 3... Where's my calculator? Did my calculator disappear? This is something weird is going on. I am going to sing. Hang on. Because if I don't, it's going to get mad at me. There you are. And it's this one. Here we go. Me. All right. No, that definitely doesn't do it. You have to wait for it. You have to wait for it. What? That was weird. Okay, anyway, 7.5 divided by 3 is 2.5. So we get 2.5 times 10 to the negative 9th. Is that number already in scientific notation, Mo? Yeah. Yes, it is. So there's our answer. 2.5 times 10 to the negative 9th. On Canvas, you would write 2.5 e negative 9 and call that a day. How many of us got 2.5 times 10 to the negative 9th for that? Beautiful. Very good. Excellent. Love to see it. All right. Miss Vivian, what would be, how would you handle this second one? What are you going to do with this guy? Sure. 2.8 times 5. 2.8, oops. 2.8 times 5, you said 14? Yeah, there you go. So that's 14, and then what did you do? And that would be times 10 to the negative 16, I think. Great. Perfect. Thanks, Vivian. Is that answer in scientific notation, Dean? Yeah. It is? Okay, cool. So then we're good. Do we all agree that it's in scientific notation? Yes. Ooh, I'm hearing yeses and I'm hearing nos. That means we better talk about it. When I say teach, you're going to say okay. Is that in scientific notation, yes or no? Why or why not? Teach! Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see, guys. Thumbs up, that's in scientific notation. Let it go. 14, E negative 16, we're done. Thumbs down, I don't think that's in scientific notation, and we need to do something before we submit a final answer. Dean, I really want to see your answer to this. What do you think? What is it? Oh, hey, hold on. Don't give me the... Dean, don't give me the answer yet. I wanted your answer to, do you still think that that's in scientific notation? No, not at all. Very good. So we need to put one there. And here's the thing. What I don't want to do is I don't want to turn this into standard form by taking this decimal and moving it 16 whole spaces that way, and then moving it, I guess, 15 spaces to where I want it to be. So we need to find a way to be able to do this and just adjust it. So the question is, if I move that, it does indeed become 1.4 times 10 to the something, but the question is, times 10 to the what? Teach! Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Okay. Elin, what do you think? That should be 1.4 times 10 to the what? Negative 17. How many of us figure that it's going to be negative 17? Ooh. Does someone have a different idea? What do you think, Dwayne? Okay. How many of us think it's 1.4 times 10 to the negative 15? Well, I will tell you it is one of those. But which one is it and why? Let's take a look. Let's back up. Let's back up. Guys, even if you've got a number in scientific notation, let's see, there we go. Or, sorry, even if you have a number that's not in scientific notation, it's still trying to follow the same instructions. According to this number, Elin, how many places does this decimal want to get moved? It wants to get moved 16 spaces to the left. But if I take this decimal and move it one space to the left, how far would it have to go from here to get to the same place, Elin? 15. And that's why the correct answer would be 1.4 times 10 to the negative 15, or 1.4 e negative 15. Does that make sense, Elin? You have to watch what direction the exponent is trying to drag it, and then decide if we're making it go farther or less far. And that's going to be a huge part of what we're up to today. It is the 60th day of school, guys. You know, the Babylonian number system was base 60, which is why time is base 60. The basic idea, guys, is we have 9 digits plus a 0 as a placeholder. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 single-digit numbers. The Babylonians had 59 single-digit numbers. So they had 1, 2, 3, 4, 5, 6, 7. Their number for 10 was a single digit. Their number for 11 was a single digit. All the way up to 60. They did that because they liked how many numbers were divisible, how many numbers 60 was divisible by. And that is why we have 60 seconds in a minute and 60 minutes in an hour. Dwayne. I'm afraid I don't have any time for that, but perhaps at the end of class if we've got it. Happy Guinness World Record Day. Today is the first day that they decided to put together a book of records in order pretty much to settle bar bets. I don't know if you guys knew that. Where like people would be like, oh, what's the fastest bird in the world? And the guy was like, I'll bet it's a hawk. And then the guy's like, oh, no, I'll bet it's a swallow. And they'll be like, oh, come on, we've got to look it up. And they went to the library and looked it up. And they're like, what? None of these books have the information we need. And so they made they were Irish. That's why it's like that. And then so they put together the Guinness Book of World Records, and it is what it is today. And in commemoration of the Guinness Book of World Records, I'm going to draw a card here. Let's see here. And it's going to land on Kenzie. Kenzie, so is there a world record you would like me to look up for you? Here's the world records I've learned so far because I've been doing this every period. Thanks to first period, I know the longest time that anyone has held their breath is 11 minutes and 54 seconds. Oh, It could, I don't know if it's, maybe it's because it was underwater, but I can tell you when you go to the Guinness Book of World Records and you look it up, it's 11:54, and that's what I'm going by. If someone did it on YouTube, I'm not counting it because there wasn't anyone there to make sure it was real. Second thing I learned was that a person was able to eat 25 full-size marshmallows in a minute without drinking any water. Yeah, that's impressive. Here's another one. There was a lady, this is what I learned in third period, a lady who was able to take a bunch of grapes and pick them and throw them up and catch them in her mouth and then ultimately eat them. She didn't like eat them like, but at the end, her mouth was pretty full and she had to like squish it down and eat it. But she was able to catch 86 grapes and eat them in a row, without missing, in 1 minute. So, Kenzie, what would you like to learn? Does someone have an idea? Does someone have an idea? Let's go, Tate. What do you think? The longest distance walked on Legos. You know what? Here's the thing. I'll tell you guys. You know, people will ask me questions like this, and I'll look it up, and it might not be a record. But if it isn't, there's going to be something that's similar. Okay, here we go. Longest distance walked on Legos. I know it's frozen because you never know what's going to come up on the Guinness World Records. Those of you at home, I also blanked the screen, so sorry. Let's see here. Oh, there we go. It's there. The farthest distance walking barefoot on Lego bricks. Holy crap. The farthest distance walking barefoot on Lego bricks was set by Salisnib Sunny Molina in the United States on the 1st of May, 2021. And holy crap, he walked 8.8989 kilometers. That is 29,195. So that's 29,000. Hold on. So that's 29,195 divided by 5280. You guys, that is approximately 5.52 miles on Lego bricks. 5.52 miles on Lego bricks. Dang. Hard pass. Okay. Can I get you in 5, 4, 3, 2, 1? I don't know about you guys. I'm trying to figure out how they did that. Did they really have like almost 6 miles of Lego bricks on a road? Or do you think you just walk back and forth? Anyway, come on up in 5, 4, 3, 2, 1. Let's see here. Samuel, what is our first essential question today? Go ahead and write that down, everybody, onto your paper. I want to see that. May we practice multiplying, beautiful, and or dividing values in scientific notation. Our Jeopardy this week is Bluey characters throughout the KA American Kennel Club. Snickers is Bluey's friend, and Snickers, according to the American Kennel Club, is part of a breed that has the famously long, low silhouette, the ever-alert expression, and bold, vivacious personality have made him a superstar of the canine kingdom. So sometimes people call him wiener dogs on Bluey. It's always like, I can't keep up because I'm just a sausage dog. He always calls himself a sausage dog. But neither of those, I'm afraid, are the official name of the breed. Does anyone know what it is? Yes, go ahead, Credence. Dachshund, or the correct pronunciation was? Dachshund. Dachshunds what we call them here in the States, but they're a German breed, so they call them Dachshunds over there. And then fruits, that's a dragon fruit. That's a dragon fruit. All right. Moving right along, guys. Got a pencil? Got a pencil? Absolutely. Let's do that. So multiplying / dividing scientific notation practice. Whew, what a mouthful. So we're going to do this, guys. We're going to be dividing and multiplying values that are in scientific notation. We have to make sure that our our results, when we give our results, they are also in scientific notation, okay? So let's start with this one. 1.2 times 10 to the negative 7th, and we're going to multiply that by 7 times 10 to the 41st. Just the world's most ski-wampus elongated rectangle that is 1.2 times 10 to the negative 7th inches this way, and 7 times 10 to the 41st inches that way. Yes, absolutely. Go ahead, guys, give it a try and teach. Mm-hmm. And then what would its area be? Mm-hmm. But does it have a lot of boxes that can fit in it, or very few? Oh, like little squares, like if it was an inch, right? Like if it's it's like 0.0000000 inches this way, and then 7 with 41 0 inches that way. Well, let's see. Can I get you guys in 5, 4, 3, 2, 1? Tate, what did you get for this? How did you get that? Okay, so but let's say, like, for instance, what do you suppose your calculator did in order to get this? Because I'm going to say, if I had to type this in my calculator every time, 1.2 times 10, I actually think that it takes more effort to type that in, the whole business, than it does to maybe do this like piece by piece. How would you do it piece by piece, Tate? Oh, so you would actually, I don't know about that. Because then you're going to have to go, so 1.2 times 10 to the negative 7 is 0.000000012. And do you really want to write this with 41 zeros coming after it? I don't think that's a great idea. Let's see what we can do. Let's see what we can do. I want to know, because it's really important. It is lovely that you guys can put this in your calculator, but I also want you to understand what your calculator is doing to do this. And in that case, we need to make sure that we can do it piece by piece. Hey, there you go. It's our first hug card. It's our hug card. You remember how Autumn, maybe you guys saw her. She was gone by the time you guys showed up. But Autumn was here on Friday because she was sick, and her grandparents needed a moment to come and get her, so she was here from her first and second periods. But the day before, she was at gymnastics because Thursday is her gymnastics day. And then what happened is that she's like, Dad, can you get me a drink, but not one with too much sugar? So I said, okay. So I went to the store, and I bought a bunch of those Hug fruit barrels. Do you guys know what those are? Those Hug fruit barrels. And I brought them back, and I was like, here you go, sweetheart. And she goes, gross, I don't like those. And I was like, all right. So, well, I'm glad you like those, because what I'm going to do, guys, when I draw that card, I'm going to ask the question I was going to ask to the next card I draw, and if I'm satisfied with the answer, they get this thing. They get this fruit barrel. C3. That's Evan. Evan, how would I do this piece by piece without just jamming it into my calculator? We do 1.2 times 7, and that's how you get the 8.4. And then what? So that would give us our times 10 to the 34. Evan, is that already in scientific notation? Perfect. And that means that you could just write 8.4 E34. And that would be your answer there. How many of us were able to get 8.4 times 10 to the 34th power there? Perfect. Sounds good. Evan, the fruit barrel is yours. You can drink it now at lunch. Bring it home. Put it on ice. I don't care. Tomorrow I'm going to shuffle in the fruit barrel card every period until they're gone. I'm going to shuffle those fruit barrels in there until they're gone. So tomorrow there'll be another one. In the meantime, got a pencil? Okay, how many of you are like, this is the most exciting thing that's happened in this class in months? All right, I don't know how to take that. That's fine. All right. 4 times 10 to the 8th power times 5 times 10 to the 12th. That's great if you can put it in your calculator, but I also want you to be able to get comfortable with doing it piece by piece. See what you guys can do and teach.
It's not even that hard. Like, it's so easy. Yeah, it's really easy.
Oh, there's only one. I shuffle it in, I draw it, and it's gone. Yeah, Dean.
You can do it on your calculator faster with the times 10.
Sure. That's true, but honestly, the less buttons I'm pushing on my calculator, the happier I am. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see here. Duane, what did you get for this? I'm glad we're talking. Tell me what you're doing. Beautiful. And then? So 20 times 10 to the 20. Beautiful. Duane, is that in scientific notation? Yes or no? No. So I have to grab my decimal, and which way do I have to move it? To the left or to the right? I'm going to move it 1 to the left, turning it into 2.0, which I'm just going to call 2, times 10 to the, well, it wanted to go 20 spaces this way. So how many spaces does it want to go from here to any? 21. So it should be 2 times 10 to the 21st power, or 2e21. How many of us got 2 times 10 to the 21st power, or 2e21? Beautiful. Let's go do a couple more, guys. Couple more. Okay, got a pencil? Here we go. 4.8 times 10 to the negative third divided by 5 times 10 to the negative 17th. 4.8 times 10 to the negative third divided by 5 times 10 to the negative 17th. See what you guys can do with that and teach. Evan, what do you think you're going to do? You're going to drink that at home or at lunch? You're going to drink it, put it on ice and drink it at home, see how it tastes? Perfect. Okay. Take another 30 seconds, guys. All right. Can I get you guys back up here in 5, 4, 3, 2, 1? Shh. Let's see. Camilla, what did you get for this? And how did you get that? Beautiful. Oops. 8 divided by 5. And then what did you do to get that 14? And that gave you your 14. Beautiful. Now, that's perfect. Exactly so, Camilla. Here's the question we have to ask ourselves, though. Sina, is that in scientific notation? It is not, because the first number in there that's not a 0 is not in the ones place. So remember, this 14 wants to take this 14 spaces this way. If I take the decimal and scooch it over to where it belongs, how many spaces does it have to go from there, Sina? So what would that make your final answer? Awesome. Does that make sense? Beautiful. How many of us are feeling confident with that? You guys doing okay? You'll love to see it. So 9.6 E13. Let's see here. I think we get out at 30, don't we? Yeah. Okay. So will you guys open up your planners to page 55, please? Page 55. Page 55. Under Thursday, November 13th. Thursday, November 13th. We're going to write down our self-assessment today, which is 9.3 multiply/divide in scientific notation. Okay? Scientific notation. And then if you guys will actually flip to page 56, I actually have a little bit of information for you there. It's official, page 56. If you go to Tuesday, November 18 plus Wednesday, November 19, there is going to be a substitute that day in class. Substitute, yep. That's correct. That is correct. So you do the review and I think you'll be doing the review and the skill check with the substitutes. The reason is, guys, is that I've been invited by the Utah State Board of Education to help them write RISE questions for your secondary math 3 class that you take. I'm going to do the best I can to make them fun. Okay, guys, this is my goal. My goal is to write a question and get it on there that is funny. That when students read it, it will make them laugh. That is my goal. And so if you see one, if you're taking the secondary math 3 RISE test years from now, I want you to look at, if you see one that makes you laugh, it's probably me. Yeah, Dwayne.
So, since we aren't in secondary math 3, when you come back, can you tell us what you wrote?
Oh, certainly not. I have to sign a non-disclosure agreement where I cannot discuss anything about what gets written. Anyway, that's all I have for you guys. So go ahead and open up your Chromebook and work on 9.3. That is multiplying and dividing values in scientific notation.